Hello students, today we are going to observe, we are going to solve a question, that is question of 14. What is asking the question? From exploration solution of describing motion around us. They are telling on entering a state highway, a car continues to move with a constant velocity of 6 meters per second for 2 minutes. That means car is maintaining the constant velocity of 6 meters per second for 2 minutes. Then accelerates with a constant acceleration of 1 meter per second square for 6 seconds. Find the displacement of the car on the straight highway after 2 minutes 6 seconds. By seeing the question, you will not be able to understand it properly. So let's solve the question first by graphically, because they have told to find out the displacement by graphical method. So you keep on your eye in your book and see the question, and here let's see the solution. Let me coming back to that page. Here I come back to the page. Okay, first you see it is a velocity time graph. Along x-axis the time is given, along y-axis the velocity is given. Okay, the velocity time graph is given, and what is told here, it is told that for the first 2 minutes, velocity of the car is maintained constant 6 meter per second, 6 meter per second, 6 meter per second. Can you see that with 0 to 2 minutes, within this range velocity is not changing? Within this range 0 to 2 minutes, velocity is constant 6 meter per second. It is not changing yet. As the for 2 minutes the velocity is not changing yet, we know the area of velocity time graph will give you what? Displacement. Area of, we know that area of velocity time graph will give you what? Velocity into time displacement. So for the first 2 minutes, velocity is how much? For the first 2 minutes, velocity is 2 minutes. For the first 2 minutes, velocity is 6 meters per second, and time is 2 minutes. And if we draw the area of this rectangular portion, this is looking like what? This is looking like a rectangle. Rectangle is what? Rectangle's area formula is length into breadth. What is the rectangle's area formula? Length into breadth. So your length is 6 meter per second, and breadth is 2 minutes. 2 minutes means 120 seconds. So if I draw the area, if I obtain the area, let's minimize it. If I draw the area, if I minimize the area, you will see area equals 6 into 120. 6 into 120. Why 120? Because time is there 2 minutes. 2 minutes goes for 120 seconds. So area will give you what? 6 into 120, 720 meter. So for the first 2 minutes, when the car was at constant velocity 6 meter per second, for the first 2 minutes the car was not changing its velocity. Its velocity was constant. That means acceleration is 0. With that velocity, how much distance car has gone? 720 meter. 720 meter. Because acceleration is constant. Acceleration is constant. The car has gone with the velocity 6 meter per second, and we know area is what? Area of velocity time graph will give you what? Displacement. And this is nothing but a rectangle. This is nothing but a rectangle, and rectangle's area is length into breadth. Length is 2 minutes means 120 second. Breadth is 6 meter per second. 6 into 120, 720 meter. Now for the next time, next 60 second, next 6 second, 2 minutes 6 seconds. See here I have drawn very minutely. This is 2 minutes time interval. After that 6 seconds, next 6 seconds, that is means it is 2 minutes 6 seconds. The car starts accelerating. The car starts accelerating. Up to 2 minutes its velocity was 6 meter per second. After 2 minutes 6 seconds, the car's velocity acquires the velocity of somewhat 12 meter per second. If the velocity is 12 meter per second, we will get this area. This is nothing but the area of trapezium. Area of trapezium. Now, you might be thinking, area of trapezium, why? Because trapezium has two parallel sides and other two non-parallel sides. So what is the formula of area of trapezium? We know the formula of area of trapezium is half into sum of parallel sides into height within height or perpendicular height between the parallel sides. I'm telling again, what is the area of trapezium formula? Half into sum of parallel sides into perpendicular distance between parallel sides. Half into sum of parallel sides into perpendicular distance between parallel sides. So if I draw the graph, you can see up to 2 minutes it has maintained 6 meter per second, but after 6 seconds its velocity accelerates to what? 12 meter per second. Why 12 meter per second? Now you might be little bit strange. Said from where we are getting the 12 meter per second? That also I am showing you. See the solution. You will see the car continues its motion with the velocity 6 meter per second for 2 minutes. But step 2, you see, in the step 2, after 6 second car accelerates with the acceleration 1 meter per second square. If the car starts with the acceleration 1 meter per second square, we know what v equals u plus at. V equals u plus at means what is the initial velocity? 6 meter per second after 2 minutes. Means 2 minutes to 2 minutes 6 seconds. I'm repeating, 2 minutes to 2 minutes 6 seconds. Within this time interval, I'm assuming 2 minutes as initial time, which started within the 2 minutes, and next 6 seconds it has accelerated with 1 meter per second square. So how it will going to be? How it will go to affect? So it is affecting like that. V equals u plus at. Initial velocity 6, acceleration 1, time 6 seconds. Final velocity after 6 seconds. After 6 seconds, the final velocity reached will be 12 meter per second. So we got after 6 seconds, final velocity will be what? 12 meter per second. How we got the final velocity? Because in the question it is told after 6 seconds it accelerates up to 1 meter per second square. If it accelerates into 1 meter per second square and you are having already initial velocity u, so with the help of formula v equals u plus at, you can easily derive the value of final velocity. Now coming back to the question again, we have to obtain the displacement with the help of graph. So here you see this is okay, wait, here you see this is a trapezium. Why trapezium, sir? Because at 2 minutes velocity was 6 meter per second. At 2 minutes 6 seconds means after 6 seconds velocity was 12 meter per second achieved. So if we take this 12 meter and 6 meter per second, 12 meter per second and 6 meter per second, these two are parallel sides. 6 meter per second and 12 meter per second, these two are parallel sides. So it is the sum of parallel sides 18. And what is the perpendicular distance between these? This thing is a perpendicular distance. And what is the perpendicular distance? 2 minutes to 2 minutes 6 seconds. This gap is only 6 seconds. So if I apply the formula of trapezium, half into sum of parallel sides into perpendicular distance between them, then we are getting half into 6 plus 12 into 6. That means half into 18 into 6, that is 54 meter. That means first area for this rectangle we got 720 meter, where the velocity was constant for 2 minutes, 6 meter per second. Their acceleration is 0, and we know that area of velocity time graph gives us displacement, and area of rectangle will be length into breadth, where length is 2 meter, breadth is 6 meter per second. From there we got 720 meter, and for next 6 seconds it was accelerating. For next 6 seconds it was accelerating. Then applying v equals u plus at, we got final velocity 12 meter per second. So 12, 6, do both parallel sides. Then by solving the area of trapezium, we are getting the value of A2. Then this trapezium area is 54. Then what is the total area? 720 plus 54, 774. Now we know that total area under this curve is 774 meter, and total area under velocity time graph gives you what? Gives you displacement. So the displacement is 774 meter. Thank you.